Hi everyone, in this video we are going to continue with our journey into functions and specifically look at linear functions and see what kind of situations can be modeled using a linear function. The ultimate goal with these functions is to be able to model things in our real life so that we can better understand them just through algebra, and the simplest such model is a linear model. And a linear model comes out of a linear function. And what does a linear function look like? So it looks like a straight line, which means that if you plot it, it looks like a straight line. So any function, the family of function that goes around the origin, y equals mx for different values of m, or y equals x plus a for different values of a as it moves left and right, those are all linear functions. Okay. Now, in terms of equation, what do they look like? They look like, in general, y equals mx plus c, or they can look like ax plus by equals 1, etc. Basically, saying that the degree of x and y are at most 1, meaning they are either 1 or 0. Now, when we talk about linear functions, they are equivalent to lines, straight lines. And one of the fundamental, let's say, characteristic that defines a straight line is the slope of the line. And what is the slope? The slope is defined by rise over run, meaning it's defined by the change in output, that is change in y, over a unit change in input, that is x. And for example, if I take the line y equals x plus 1 and I plot this line, when x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 3, and so on. So x0, it's over here, here, and here. And that is what my line is going to look like. Now, what is this slope thing? The slope thing says that if I change my input by 1, I notice that my output changes by exactly 1. And then I change my input again by 1, and my output changes again by 1. So which means that I'm taking steps of size 1 horizontal, 1 vertical, and it will put me on this line. The formal definition says that the rise is 1 and the run is 1, so the slope is 1 over 1. Or equivalently, I can think of this as change in output or change in y divided by change in input, which is change in x. So here, for example, in both of these cases, my output changed from 2 to 1 as input went from 1 to 0, so that's 1 over 1. Or I can say the output changed from 3 to 2 as I went from 2 to 1, which is also 1 over 1. And these are equal, and they are both equal to the slope. Now, to illustrate the difference, let me show another line, say 2x plus 1. Now, in this case, when x is 0, y is 1. When x is 1, y is 3. When x is 2, y is 5. So here, that's what the line looks like. And in fact, now if I look at the change between 0 and 1, the rise is 2. And between 1 and 2, again, the rise is 2. So here, the change in y over change in x, this is 3 minus 1 over 1 minus 0, which is 2. Or it is 5 minus 3 over 2 minus 1, which is also 2. Okay, so what this tells us is that this quantity, now that is nothing but an average rate of change. It tells us that the average rate of change is exactly the slope for a straight line. That is, for a linear function, the slope represents the average rate of change. Now the easiest way to find that is to express these straight lines as y equals mx plus c. And in that form, m represents the slope. So the first one, we have a 2y, so I'm going to get rid of that by dividing everything by 2, and I get 1.5x minus 0.5. So the slope is 1.5, and that is also the average rate of change. Yeah, it's the same thing. This one, the slope is directly 0.7, which is also the average rate of change. And here it would be negative 7/3 x minus 5/3, so that is the average rate of change or slope. So the takeaway here is that for linear models, linear functions, things represented by straight lines, the slope of the straight line represents this very physical or real quantity called the average rate of change, which is how much the output changes for a certain change in the input. In the next video, we're going to look at some examples of setting up the model and finding out what the graph, what kind of information the graph gives us, what kind of information the slope gives us, and just explore it a little bit more. That's it for this video.